number one, solve the system by graphing. So when we look at this on our first equation, m equals 4, that's our slope. We get that from the number in front of x. And we're going to make that be 4 over 1 because remember we want the rise over the run. The other number, the other 4, tells us our y-intercept. And remember that that's what that is because a lot of people forget and try to put that on the x-axis, but don't do that. It's the y-intercept, so it goes on the y-axis. There is a connection there. So you put a point at 4 on the y-axis because that's what b is. You would go up 4 over 1 to put your next point, but that goes off our graph. So we definitely need to go the other direction, which is down 4, left 1, and go ahead and keep going because we don't know which ones of these points our graph is going to actually intersect at. So here's our first line. Our second line is going to have a slope of 1/2 because remember that's what's next to x, and a y-intercept of -3. So you go down to 3, and then our slope, our rise over our run, is up 1, right 2. Well, if I keep going this direction, I'm not getting any closer to that other line. So make sure you go down 1, left 2, and oh look, they intersect there. So the answer on this is the point where those intersect, which is right here, which is at -2, -4. So that's what we would put for our answer.
Solve the system by the substitution method. So the substitution method is where if we have a variable solved for, like in this case we have x solved for, we can take the rest of this and plug it into our other equation. So plug it in like right here in this equation for x. So that's going to give us 5 times -4y plus 4 minus 7y equals -7. Then we just need to solve this. So we've got to distribute, and we get -20y plus 20 minus 7y equals -7. Add like terms. -20y minus 7y is -27y. We can also subtract this 20 over to the other side so that this equals -27. Divide both sides by -27. And y equals 1. Take that, since we know what y is, and put it back into one of these first two equations. The easier one will be this one that's already solved for x, because we can say x equals -4 times y, which is 1, plus 4. -4 times 1 is -4 plus 4 gives us 0. So x is 0, y is 1, and that's our answer. Again, we're solving by substitution. This time though we're solved in this equation for y. So this right here, that y equals, we're going to plug in to y this time instead of x. You always have to pay attention to what you're solved for. So 2x plus 9 times 3x plus 13 equals -8. Then we need to distribute and add like terms. So 2x plus, oh, not plus, because 9 times -3x is 27, -27x. 9 times 13 is 117, equals -8. Add up your like terms. On this side, 2x minus 27x is -25x. We can also subtract the 117 over to the other side. -8 plus -117 is -125. finish it off by dividing both sides by negative 25. X equals positive 5. Then you take this and plug it back in up here so that we get y equals negative 3 times 5 plus 13. Negative 3 times 5 is negative 15. Negative 15 plus 13 is negative 2. So our answer is x comma y, which is 5 comma negative 2. Alright, number 4, we're going to start a new section of instructions, solve the system by the addition method. That's also known as the elimination method, and that's, I think, what I probably called it more often was elimination instead of addition. On this, what you're looking for is you're trying to add the equations together to where one of your variables cancel out. And so in this particular case, if I add them together right now without doing anything at all, we'll actually get the x's to cancel out because we've got 3x and negative 3x, and together those would make a 0x. Then we just keep adding together our two equations. So 5y plus the negative 11y is negative 6y. Negative 22 plus 52 is 30. So we can divide both sides by negative 6 and get y equals negative 5. Now we have to find x, so we take this and we plug it back in up here into one of our first two equations. So I'm going to pick the first one. You can pick either one and it doesn't really matter, but 3x plus 5 times y, which is negative 5, equals negative 22. And we have to solve this now, so 3x, 5 times negative 5 is negative 25, equals negative 22. Add 25 to both sides so that 3x equals 3. Divide by 3 and x equals 1. So our answer on this is 1 comma negative 5. Same set of instructions here. We're using the elimination or addition method, and so we're trying to add our equations together so that everything, or not everything, but so that our x's or our y's will cancel out. If we try to add right now, we have 5x plus 5x, which would give us 10x, which isn't going to cancel out, neither are the y's. But if we choose to multiply one of our two equations by a negative 1, then we'll end up being able to cancel out because it'll change the signs on this first equation and give us negative 5x. We could do it to either of those equations in this case since they had the same number in front of the x's on both. So I chose to do the first one. Now we can eliminate 5x minus 5x. 2y minus 8y is negative 6y. 42 minus 18 is 24. Divide by negative 6. And you get y equals 4. Then you take that and plug it back into one of these equations that we started with. And it doesn't really matter which one, so I'll pick the first one. 5x plus 8 times y, which is 4, equals 18. So 5x plus 32 equals 18 because I did 8 times 4. Subtract 32 from both sides. We get 5x equals negative 14. Ooh. Negative 4 for y. 24 divided by negative 6 is negative 4, so this is negative 4. So this is minus 32 plus 32 on both sides, which gives us 50. So I knew that there was a chance that that was wrong because I ended up with a fraction. I mean, it's not necessarily true that you couldn't get fractions here. It's a bad sign if we get a fraction. We need to check our work. So see now, because I corrected my mistake, I got x equals 10, y equals -4. Very important to watch your positives and negatives. Number 6, elimination again, but this time it's even more tricky because I can't just add or subtract my equations. I actually have to figure out something to multiply by. If we look at our x's, if I want to make a 3 and an 8 match up, I'm going to have to multiply both of them by something. Okay, if I look at my y's, 16 and 4, if I multiply the second one by a 4, I can get 16. And it's good that they already have opposite signs because that's what allows us to cancel out there, is if they have opposite signs. So multiply this by a positive 4, which means we need to distribute 32x minus 16y equals -16. I'm going to go ahead and rewrite the top equation here. And see what cancels out. 32x plus 3x is 35x. The y's cancel. -16 plus 16 is 0. I divide both sides by 35. Zero divided by 35 is 0. So then I take this and I plug it back into one of these equations up here. So I'm going to pick the first one, 3 times 0 plus 16y equals 16. Well, that 3 times 0 is just 0, so that's going to go away. We divide by 16 on both sides, and we get y equals 1. So our answer here is 0, 1. Solve the problem. A college student earned $8,800 during the summer vacation working as a waiter in a popular restaurant. The student invested part of the money at 8% and the rest at 7%. If the student received a total of $651 in interest at the end of the year, how much was invested at 8%? So there's a couple different ways of doing this. The way I like to do it is first you start off by saying what your variables are. So I'm going to use x to represent the amount invested at 8%. And then I'm going to use y to equal the amount invested at 7%. So what happens with investments like this is we know that the total that the person is investing is $8,800, which means our two investments, x and y, have to add up to be $8,800. The other equation is going to deal with our interest rates. And so our interest rates are 8% and 7%, and they end up giving the person $651 in interest. So we would put in 0.08x plus 0.07y equals the interest 651. So see how all those interest things in our problem, the percents and the actual interest earned, those all went in the same equation. That's going to make it easier if you can remember that. Now what they asked us for was how much was invested at 8%. And that means that we need to figure out what x is. To figure out what x is, we actually, in a system of equations, do kind of the opposite of what you would think we should. We need to, if we use substitution here, we would need to solve this for y in order for us to end up with x as our first answer. So to do that, I would move this x by subtracting it over to the other side, so that I have y equals 8,800 minus x. That means that I can take this by substitution, plug it in where this y is in this equation. So that gives me 0.08x plus 0.07 times 8800 minus x equals 651. So I need to distribute. So we have 0.08x plus 0.07 times 8800 is 616. 0.07 times negative x is negative 0.07x equals 651. We've got like terms for our x's, and see how now we have x's that we're solving for, so it's all going to work out to give us x first. 0.08x minus 0.07x is 0.01x. We can subtract the 616 over to the right side. So that's going to be 35. Divide both sides by 0.01. And x equals 3,500. That's dollars because it's the amount we invested, which was dollars. And since we figured out x, which was what was invested at 8%, and that's what they asked us for, we don't have to plug in and find the other one. But if for some reason we did need to, we would just take that and plug it back into this equation and figure out what y is. Julie and Eric row their boat at a constant speed, 21 miles downstream for 3 hours. So we need to remember this formula. Distance equals rate times time. So the distance here is 21 miles. So we're going to put that on the left side. And 3 hours is our time. So that'll go after our rate. But our rate, as we're going downstream and we're helped by the current, since we're in a boat, we're going to use B for our rate of our boat and C for the rate of our current. Okay, so the boat speed plus the current speed is what happens when we go downstream. Those help each other out. The next sentence, rowing at the same rate, the trip back against the current takes 7 hours. Well, we're going the exact same distance, so the 21 is still the same. Takes longer though because now we're fighting the current. Fighting the current means that we should subtract these. Now you can distribute here and solve, or you can just divide by the 3, get 7 equals B plus C, divide by the 7, and get 3 equals B minus C. And now we have a really easy elimination problem to solve. Now, they ask us for the rate of the current. If we solve it this way, it's actually going to give us boat first, but it won't be that hard to find current after we know the speed of the boat. 7 plus 3 is 10. B plus B is 2B. Divide by 2 on both sides. We get 5 equals B. Then that means that if we plug that back in up here, 7 equals 5 plus C, I would subtract 5 from both sides and get that the speed of the current is 2. So our answer would be 2 miles per hour. We want to determine if the given ordered triple is a solution of the system. This ordered triple gives us the x value, the y value, and the z value. What we want to do to figure out if this is a solution is plug in the x, the y, and the z and see if each of these statements is true. If all of them are true, our answer is yes. If any one of them is not true, our answer is no. It has to work for all of them. So let's start at the top and go down. X is 1 plus y is negative 2 plus z is negative 5 equals negative 6. 1 plus 2 plus negative 5 is negative 6. So this is true. So the first equation works out. Then we move on to the second one. So 1 minus y, which is negative 2, plus 3 times z, which is negative 5, equals 0. So that's 1 plus 2, because negative and negative cancel out and give us positive. 3 times negative 5 is negative 15, equals 0. This is going to be negative 12 equals 0, which is not true. So our answer is no, and we can stop. If it did work out on this one, we'd have to keep going and try it in the third one. But since we were fine on that, it was a no, so we can stop. All right, solve the system by hand using elimination. So what we want to do when we solve a system of 3 variables by elimination is we want to use 2 of our equations and cancel out a variable. Then we want to use 2 more equations and cancel out the same variable again. So I look at this and I say, hey, my y's right now are just ready for me to add these 2 equations together, the first and the third one. I'm ready and raring to cancel out the y's. So I'm going to rewrite the first 2 equations down here. And then I'm going to cancel out my y's. So x plus x is 2x, z plus 3z is 4z, negative 9 minus 9 is negative 20. Then I want to look back up here. I canceled out my y's once, so that's what I need to do again. I have to use the third equation now, but I can use either the first or the second one with that third one. So I think I should use the second and third one because, again, I'll be able to cancel out my y's without even having to do anything. So x minus y plus 3z equals negative 9. 4x plus y plus z equals negative 23. And then we add those together. Our y's cancel. X plus 4x is 5x. 3z plus z is 4z. And negative 9 minus 23 is negative 32. Now both my equations have x and z, and that's what I was going for. Now I need to say how could I eliminate either x or z. 2x and 5x, those are going to be difficult to get the same number in front of. But 4z and 4z already have the same number 4. We just need one of them to have a negative instead of a positive. So pick one of them and multiply it by a negative 1. And then I'm going to write it underneath the other equation. So negative 5x minus 4z equals positive 32, since 32 was negative before that. Add our equations together and cancel out our z's. 2x minus 5x is negative 3x. Z's cancel. Negative 20 plus 32 is 12. Divide by a negative 3. And x equals negative 4. That's one number. Now we need to plug that into an equation that has 2 variables like this one right here. So 5 times negative 4 plus 4z equals negative 32. 5 times negative 4 is negative 20 plus 4z equals negative 32. Add 20 to both sides. 4z equals negative 12. Divide by 4 on both sides. And you get z equals negative 3. So now I need to take both of these, the x and the z, and plug it back into one of my first 3 equations. It doesn't matter which one. I'm going to pick the first one because all of my variables are positive and I feel like that'll be helpful. So x is negative 4 plus y plus z, which is negative 3, equals negative 11. So negative 4 plus a negative 3 is negative 7. Then I can add 7 to both sides. And I get y equals negative 4. So my point, x, y, z, is negative 4, negative 4, negative 3. Now we do it another time. This is also elimination, so if you haven't already, give this one a try and see if you can do it, because you'll have to do it by yourself for the test anyway. So if you can't, then just start the video back up and see what's going on. So on this, let's pick the z's this time since we picked the y's last time. I think the z's look like a pretty good idea. If I take the second and third ones and I add those together, I'll be able to cancel out my z's. So the z's cancel. X plus x is 2x, y plus y is 2y, and 8 plus 2 is 10. Now I need to go back to my original equations and cancel out again, and I need to cancel the z's again. So don't go and try to cancel out the y's or the x's this time. I have to cancel out the z's again. Well, the third equation has a negative, and I need to use the first equation, which has a positive. So I think that those two would be good to do together. So x minus y plus z equals 0, and x plus y minus z equals 2. And so something actually kind of helpful happens here, because not only do my z's cancel, but my y's also cancel, which will save us a little bit of time. X plus x gives us 2x, 0 plus 2 gives us 2. Divide both sides by 2. You get x equals 1, so we already found our first thing. Now let's go back and put in our x somewhere where we have two variables, which is over here. So 2 times 1 plus 2y equals 10. 2 times 1 is just 2, so subtract 2 from both sides. 2y equals 8. Divide by 2. Y equals 4. So that's x and y. Let's go back and plug in for z up into one of these first equations. How about if we pick the middle one since it has all positives? So x plus 4 plus z equals 8, which I'm going to scoot over here. 5 plus z equals 8, so subtract 5. Z equals 3. Our answer is 1, 4, 3. Alright, on 12 and 13, our instructions say write the system of linear equations represented by the augmented matrix. And I think it's helpful for you to know that these two are supposed to be easy questions to help you in your grade, because we're just taking these two matrices and writing them with x and y if it's a 2 by 2 like 12, x, y, and z if it's a 3 by 3 like 13. So you have to remember that when we have matrices like this, we have an x column, a y column, and then this line is where we put our equal sign. So this would be 13x plus 7y equals 17, and 9x plus 6y equals 19. And that's it. That's all we have to do. It just wants us to write it like that. On 13, we have x, y, z, and then our equal sign. So this will be 2x plus 3y plus 8z equals -2. 5x, where we have 0, we could put 0y, but that means there's nothing there for y. So we could just like leave a space and then move on to z and put plus 3z equals 4. And then 5x plus 6y. This time there's not a z, so we could skip that spot and then put equals 2. So that would be our answer on 13. Now for row operations. In these row operations, we're just doing individual things, whatever they tell us here. We're not actually solving for anything. So on 14, this says row 1 switched with row 2. That's what the double-sided arrow means. So the first row here is row 1, then we have row 2. So we just need to take what those are and switch them around. So I'll have 3, -7, 6, and then -8, 0, 5. And that's all they're asking us to do. 15, they want us to do 1/5 times row 1. Okay, so of these two rows, row 1 is the first row. We're going to take everything in this row and times it by 1/5. Now, that means, that's the same, by the way, timesing by 1/5 is the same as dividing by 5. So we should get for our first row 1, -5, 2. For our second row, it stays what it was because all we were doing is multiplying something by row 1. We weren't messing with row 2 at all. That would be our answer. 16 is where it gets a little tougher. -2 times row 1 plus row 2. What we're doing is we're using row 1 and then adding it to row 2, but we're not actually going to change what row 1 is, and we're not actually going to change what row 3 is. We're just changing what row 2 is. So go ahead and in your matrix, rewrite what row 1 and row 2 are so that you know, hey, not going to change these. So to figure out what row 2 is, I'm going to take what's in row 1, which here is a 4. I'm going to say 4 times -2 is -8. Add that to what's in row 2. -8 plus -5 is -13. Then I'm going to do it again. -4 times -2 is +8. Add it to 0, and I get +8. 1 times -2 is -2, plus 1 is -1, and then 1 times -2 is -2, plus -2 is -4. So that's it.
Okay, 17, solve the system using row operations at matrices. So this is the hint that we're trying to give you to remind you how you're supposed to do this. Is you're using row operations, so like switching the rows and multiplying the rows and all that stuff. One thing that's really helpful, going to be helpful, is if you know what your goal is. If you don't know what you're trying to get, it's going to be very difficult to do this problem. So what we want is 1s on our diagonal, 0 underneath the diagonal, then everything else can be numbers. So at most we should maybe have to do 3 things because there's 3 things we're trying to get. So we start off, by the way, up here at the top. We want to get this 1 and then get this 0 and then get this 1. Order does matter. Let's write this as a matrix. So we'd have 1, 1, put a line where your equal sign is, and then -9. Then 1, -1, 13. And what we should be able to do now is look at our goal and say, okay, what should I get first? Well, normally we get a 1 up here in the top left first, but we already have a 1 in the top left. So we actually don't have to do that one right there. Next we get a 0 here where this 1 on the bottom left is. And to do that we can't just multiply by 0 because that'll change everything and we don't want that. We need to think, what could I multiply this first row by so that when I add them together I get a 0 here. And so if I multiply this by a -1 and add it to this, then I will get 0. So we write that in our notation as -1 row 1 plus row 2. So when we do that, the first row doesn't change, okay? Because we don't want anything from our goal. Nothing's happening there with the first row. What we're trying to do is get a 0 in the second row, so that's the only thing that's going to change is the second row. And what we're going to do is say -1 times what's here and add it to the second row. So 1 times -1 is -1, and then add it to this one, and that gives us 0, which is what we were going for. 1 times -1 here gives me -1. -1 plus a -1 is -2. -9 times -1 is +9. +9 plus 13 gives us 22. So now what we need to do, because we just got our 0 right here, we need to get a 1 where the negative 2 is. When we're trying to get a 1, what we do is we do 1 divided by whatever that number is that we're basically trying to get rid of. And we're trying to do this to row 2 because that's where I want the 1, is in row 2. So because this was a negative 2, that's what's on the bottom of my fraction. Multiplying row 2 by negative 1/2 is the same thing as dividing by a negative 2, which is how that's why this works, that we get 1 here, because negative 2 divided by negative 2 is 1. So we're not changing the first row, we're just changing the second row. 0 divided by negative 2 is still 0. Negative 2 divided by negative 2 is 1. 22 divided by negative 2 is negative 11. So we've got our goal. We've got the 1, the 0, and the 1. So here's what we do next. We write this back as a system of equations where this is an x column, a y column, and here's our equal sign. This gives us 1x plus 1y equals 9. 0x, so we don't write that. Y equals negative 11. What happens is we can really easily take this y equals negative 11 and plug it into the first equation. So x plus a negative 11, so that's really x minus 11, equals 9. So this was negative 9 this whole way through, guys. My bad. I accidentally dropped that negative. But now that I put it back, when I add 11, I get x equals 2. So my point for my answer is 2, negative 11. Alright, number 18 asks us to use row operations to solve this matrix. So one thing that you have to know in order to do this is what we're even trying to get to. So we are trying to have at the end of this a matrix where, here we go, a matrix where we've got 1s on our diagonal, we've got 0s underneath the diagonal, then we don't care what any of the rest of our matrix is, we just need them to be numbers. So this down here is our goal. And we do this very methodically. We have to start up here at this 1 and go down. Once we're done with the first column, we start at the 1 in the second and go down. Then we get this last. So we first need to write this as a matrix. So you take the numbers in front of the variables. So we get 1, 1, 1, 9, 1, negative 1, 5, 17, 2, 1, 1, 13. That's how we start out. So notice if we look back at our goal, we've got the 1 in the top left, which means we don't need to move anything or multiply or do anything to get that first thing. It's already there. But we do need to get a 0 right here where this 1 is. And to get that 0 here, we need to say, what could I multiply this first row by so that I have a number here in this first spot that when I add the rows together, I get a 0. Well, we need to multiply by a negative 1 because negative 1 plus 1 gives us 0. So what we're doing is negative 1 row 1 plus row 2. When we do this, we're only trying to change row 2 because that's where we want the 0. That means row 1 is going to stay what it was, and row 3 is going to stay what it was. We need to figure out what will row 2 be. So everything in this first row, we're going to multiply by a negative 1, then add it to row 2. So 1 times negative 1 gives me negative 1. And then I would add that to the second row, which is 1, and get 0. 1 times negative 1 on the second element would be negative 1, and then I add it to row 2, which is negative 1. Negative 1 plus negative 1 is negative 2. 1 times negative 1 is negative 1. Negative 1 plus 5 is negative 5. No, just kidding. Negative 1 plus 5 is 4. Whoopsie. Sorry about that. And then negative 1 times 9 is negative 9, plus 17 is 8. Okay, so now we've got that 0 down there in the middle taken care of. So we need to get the 0 in row 3. So we need to say, what would I multiply again using row 1? What could I multiply this 1 by so that when I add row 1 and row 3 together, they cancel each other out? So we need a negative 2 right here. So we do negative 2 row 1 plus row 3. So this time the only row that's changing is the row that I'm trying to get a 0 in. So the first row will stay what it was. The second row will stay what it was. The third row, we have to do negative 2 times our first row and then add it to the third row. So negative 2 times 1 is negative 2. Negative 2 plus 2 is 0. 1 times negative 2 is negative 2. Negative 2 plus 1 is negative 1. Negative 2 times 1 is negative 2, plus 1 is negative 1. 9 times negative 2 is negative 18. Negative 18 plus 13 is negative 5. So we're done with the first column. We've got it the way we want it. Now we need to go to the second column, and we don't care what this first number is, this 1 up here. It doesn't matter what that is. We want to make there be a 1 right here in the middle where this negative 2 is. When we want to get a 1, what we do is we multiply by 1 divided by whatever this number is that's right here. So since it's a negative 2, I'm going to do 1 over negative 2. I'm timesing it by row 2. So I'm going to write this new matrix over here. Only row 2 is changing because that's where we wanted to get a 1. So we can leave the other two the way they are. And now 0 times a negative 1/2 is still 0. Negative 2 times negative 1/2. Remember that multiplying by a negative 1/2, that's like dividing by a negative 2. So if that makes it easier to work this out, then think of it that way. So that gives me 1 here, which is what we were going for. 4 divided by negative 2 is negative 2. 8 divided by negative 2 is negative 4. So that's the 1 that we wanted right here. Oh, we already got that 0. So now we need to get a 0 here where negative 1 is. So we can't use row 1 anymore to do this, because if I try to do like something times row 1 and add it to row 3, I've got this 1 here that's going to change this 0, and I don't want that. Once we're done with this first column, we have to start using the 1 here in the middle instead. So in this case, I just need to add row 2 and row 3 together, and I'll get a 0 right here. So R2 plus R3. So we get 1, 1, 1, 9, 0, 1, negative 2, negative 4. That was all the stuff that wasn't going to change. We're just changing row 3 right now because we're just trying to get this 0 here. So we add these together. 0 plus 0 is 0. 1 plus a negative 1 is 0. Negative 2 plus negative 1 is negative 3. Negative 4 plus negative 5 is negative 9. So that's the 0 that we wanted down here in our goal. Last thing we want is we want to get a 1 where that negative 3 is. So just like we did a second ago up here, to get a 1 we need to do 1 divided by negative 3 times the row we want the 1 on, which is row 3. So 1, 1, 1, 9, 0, 1, negative 2, negative 4. That's all what's not changing. And now both of these zeros, if we multiply them by anything, they stay zeros. Negative 3 times negative 1/3 gives us 1. Negative 9 times negative 1/3. That's like dividing by negative 3, so that gives us 3. once we're at this point, once we've got our goal met, we say, okay, let's write this back as a system of equations. So we have an x column here, a y column, a z column. Remember, the line is where your equal sign is. So this would be 1x plus 1y plus 1z equals 9. 0x, so we don't need to write it, 1y minus 2z equals -4. No x or y in the last one, just z equals 3. And the whole reason that our goal was what it was so that this is really easy to go backwards and solve, because I know z equals 3, so in this second equation I can put that in. Y minus 2 times 3 equals -4. This is going to be -6, so I just need to add 6 to both sides. So y equals 2. So I have z and y, and I plug it back into the very first equation. X plus 2 plus 3 equals 9, which is x plus 5 equals 9. So x equals 4. And that's all there is to that.
Find the determinant by hand. So this is where we have to show our work in order to get full credit. Otherwise it doesn't look like we did it by hand. Take the diagonals. So 3 times 4. That's one diagonal. You subtract the other one. 7 times 2. 3 times 4 is 12. 7 times 2 is 14. That equals -2. That's our answer. All work shown shows that we did it by hand and not on the calculator. Alright, use Cramer's rule to solve the system. This was on 3.4 part 1, so if you're like, I don't know where you're getting all this, that's where I'm getting it from, 3.4 part 1. Find your notes and look at them. And what we have to do on this is where in our notes we have x equals, and we've got this matrix over another matrix, so it kind of looks like an H. And we have y equals, we have a matrix over a matrix, and then inside of those we have a bunch of A, B's, and C's. And the tricky part on here is understanding where we get the A's, the B's, and the C's from. So our A's come from what's in front of x. Our B's come from what's in front of y. Since this doesn't have anything, that's a 1. It's our B's. And then our C's are this last part. So what we do is everywhere you see A, I want this to be a different color for C because I already used that other color. Okay, wherever you see A in your chart, you're going to put 3 and 3. That happens at the bottom left, the bottom right, and the top right of our matrices. Then we go in and we fill in our B's. Again, this is in section 3.4, or in my class, this is on the back of your review. I'm not sure, I think Miss Williams gave it to you somewhere, but probably not on the back of your review. So, if nothing else, it's in 3.4 part 1. And then our C's go here, 11, -5, 11, -5. So we need to do the determinants of each of these matrices. So let's start on the bottom because these two on the bottom are both the same. So 3 times 1 minus 3 times 5. That would be 3 minus 15, which equals -12. So on the bottom of each of these, I have -12. Then we would look at the top. 11 times 1 minus -5 times 5 gives me 11 plus 25, which is 36, which means 36 over -12 is -3, so x is -3. And then over on the right side here, 3 times negative 5 minus 3 times 11 is negative 15 minus 33, which is negative 48, which gives us positive 4. So our answer, x comma y, is negative 3 comma 4. 21, this tells us to evaluate the determinant by hand. This is a 3 by 3 determinant, so this is how we do it. We recopy the first two columns next to our matrix. So 1, 2, 1, 5, 6, 1. And we do this to make it easier to tell what our diagonals are, because I need to look at my diagonals going this direction. I've got 3 of them. So in my first diagonal, I have 1, 6, 1. Then I have 5, 2, 1. Then I have 6, 2, 1. Because all of these are going the same direction, I add them together. I figure out what this is. This is 6 plus 10 plus 12, which gives us 28. Then I look at my diagonals going the other direction. So 1, 6, 6 plus 1, 2, 1 plus 1, 2, 5. So 36 plus 2 plus 10 equals 48. What we do, just like with the other determinant, we subtracted our diagonals. We're going to subtract these two numbers because 28 is our diagonals going one way minus 48 is our diagonals going the other way, which gives us negative 20.
22, Cramer's rule. If you haven't already looked at the back of your review, if you're in my class, and I don't know if Miss Williams showed you with her class, she probably did, what I'm going to give you for, or what we're going to give you for Cramer's rule. It's just exactly what we gave you on the notes. So what you have to do with this is fill in, you have the x equals, and you have a fraction with the matrix on top, matrix on bottom, y equals with the matrix on top and a matrix on bottom, and you have z equals with a matrix on top and a matrix on bottom, and you have a whole bunch of a's, b's, c's, and d's. So what we have to do, I'm going to put some ones in here, by the way, right here where these coefficients are. What you have to do is figure out what a, b, and c are. So this right here, the numbers in front of x, those are my a's. The numbers here in front of y, those are b. The numbers in front of z, don't forget about that negative, those are c. And last, we have the numbers on the other side of the equal sign are the d. And then in your notes or on the back of the review, you need to fill in the a's, the b's, and the c's. So starting with the a's, 5, 1, and 4 go everywhere that you see a's. So that's here, 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 here. Okay, the only place on the left side on the top or bottom they aren't is here on the top of x, because we're solving for x. Next, the b's go 8, 6, 1. 8, 6, 1 here, 8, 6, 1 here, 8, 6, 1, 8, 6, 1. Oh, just kidding, they're not on the top. Got a little carried away. That's the only place the b's aren't at. 8, 6, 1, 8, 6, 1. Now c is -1, 6, 1. -1, 6, 1, negative 1, 6, 1, negative 1, 6, 1, negative 1, 6, 1. Not on the top of the last one, negative 1, 6, 1. Now these three places we have left, that's where D should go. So 41, 56, 40, 41, 56, 40, 41, 56, 40. Now, you can do these by hand, and there's an earlier problem that shows you how to do them by hand, but as long as you're doing Cramer's rule itself, it's okay for you to use your calculator. And since there's some pretty big numbers here in our matrices, it might be a good idea, no matter what, to go ahead and use your calculator. But it's up to you. If you don't want to use it, you don't have to. Here, and I have a separate video where, and I'll link to it, that will show you how to do these on the calculator in case you forgot. So up here on the top of X, we should get 1656. The bottom of X, we should get 207. If you divide those, you get X equals 8. Here, Y is going to be 207 over 207, which means that Y equals 1. And here, Z is 1449 over 207. So Z equals 7. If we write this as a point, XYZ, that's 8, 1, 7.